The comfortable lie about space: when you look up at the night sky, it feels peaceful. Black background, a few scattered stars, plenty of empty space in between, nothing happening, nothing there. That picture is comforting, and it's almost completely wrong. We grow up with the idea that space is just a place where things happen. Like a stage, objects move around on it. Events unfold in it. But space itself just sits there doing nothing. That idea works fine when you're throwing a ball or walking across a room. Your brain evolved to deal with meters, seconds, and solid objects. At that scale, space behaves politely. It stays out of the way. But the moment you push beyond everyday experience, the idea starts to fall apart, because space is not empty, not even close, and it's not passive. The most dangerous misconception in physics is the belief that space is nothing. Once you believe that, you stop asking the most important questions. You assume the universe is built out of things, particles, planets, stars, and that space is just the gap between them. But what if the gap is the main event? What if the stuff is just a temporary disturbance? Here's the first crack in the picture. If space were truly empty, absolutely empty, nothing could happen in it. No energy, no motion, no change. Empty means nothing to work with. But space allows light to travel. It allows forces to act. It allows energy to exist. And that already tells you something unsettling. You can't get behavior out of nothing. So space can't be nothing. Even when there are no particles around, space still has properties. It has rules, it has structure. It can stretch, it can bend, it can store energy. And once you admit that, the comforting image disappears, because now space is no longer a background. It's a participant. Think about gravity for a moment. The old picture says objects pull on each other across space. But the deeper picture says something very different. Objects change space, and space tells objects how to move. That means space is doing something, not metaphorically, physically. And that should bother you. Because if space is active, then emptiness is an illusion. There is no such thing as nothing happening. Even in the quietest region of the universe, even in the darkest void between galaxies, space itself is busy doing what? Holding fields fluctuating, enforcing constraints, allowing possibilities and forbidding others. You just don't notice because your senses are blind to it. This is where intuition fails hard. We imagine space as absence because we can't touch it, smell it, or see it directly. But that's a biological limitation, not a physical truth. You can't see air either, but it still pushes back when you move through it. Space pushes back too, not in the way air does, in subtler, stranger ways. Ways that only show up when you look very carefully, or very far, or very small. And here's the unsettling part. The deeper you look into space, the less solid everything becomes. Stars turn into nuclear reactions. Atoms turn into probability clouds. Particles turn into excitations of invisible fields. And space stops being the container and starts being the substance. Once you really accept that, the universe stops feeling like a collection of objects floating in nothing. It starts feeling like one continuous system, vibrating in complicated ways. And that raises a disturbing question. If space itself is active, if it has structure and energy and behavior, then what exactly are you moving through? And what happens if you look too closely? That's where things stop being comforting. Empty space refuses to stay empty. Now let's do something that sounds simple but never is. Let's try to imagine nothing. No particles, no light, no heat, no motion. Just empty space, stripped clean. You'd expect silence. Stillness, zero. That expectation is wrong. When physicists actually calculate what should happen in completely empty space, the math refuses to cooperate. The equations keep producing activity. Tiny, unavoidable activity. Space won't sit still. Even when there's nothing in it, fields still exist. And fields are not decorations. They're physical. They can store energy, fluctuate, and interact. So here's the strange part. If you remove every particle from a region of space, you don't get zero energy. You get the lowest possible energy. And that lowest possible energy is still not nothing. It's restless. This is not philosophy. This shows up in experiments. Take two metal plates, put them extremely close together in a vacuum. No air, no particles between them. According to common sense, nothing should happen. But the plates move. They attract each other, not because of magnets, not because of charge, because empty space behaves differently between the plates than outside them. That's not poetic language. That's measurable force coming from what we insisted on calling nothing. The vacuum has rules, and when you constrain those rules, space reacts. So now the picture changes again. Space is not just active. It's unstable, not violently unstable, quietly unstable, like a surface that looks calm, but is actually vibrating too fast for your eyes to follow. At very small scales, space is full of temporary events. Pairs of particles appear and disappear. Energy briefly concentrates, then dissolves back into the background. You never see these events directly because they vanish too quickly. But their effects add up. They shift energy levels. They bend trajectories. They alter what's possible. And here's the uncomfortable implication. If space is fluctuating everywhere all the time, then absolute stillness does not exist. There is no perfectly calm moment underneath reality. The universe hums, and it hums even when no one is listening. This also ruins another comforting idea, that the universe is fundamentally solid. We like to believe that beneath all the motion, there's something firm holding everything together. But when you look closely, solidity evaporates. Matter becomes interactions. Interactions become fields. Fields exist in space, and space itself refuses to be quiet. So what's left? Not objects in space, but patterns of space. That's a radical shift. It means particles are not little beads flying around. They're behaviors, localized disturbances, notes played on a very strange instrument. And the instrument is the universe itself. Once you see that, the question, what is space, becomes unavoidable. Is it a thing? Is it a substance? Is it a system with its own degrees of freedom? Whatever the answer is, it's not nothing. And here's where things start getting unsettling instead of just weird. If space has energy, even a little, then the total energy of empty space should be enormous. Space is everywhere. Stretch it across the universe and even tiny fluctuations add up. But when we measure the universe, we don't see that energy behaving the way we expect. There's a mismatch, a huge one. The vacuum seems to have energy, but not as much as theory predicts, or maybe it does, but it hides it extremely well. Either way, there's something we don't understand, and that's dangerous. Because when the vacuum doesn't behave the way your equations say it should, it means you don't really know what space is. You're standing on something you can't see, can't touch, and can't fully describe, and you're calling it empty. That's confidence without justification. And space has a way of punishing that. The field beneath everything at some point, you have to let go of the idea that the universe is made of things. That idea is useful. It helps you build tables and predict where planets will be tomorrow, but it's not fundamental. Underneath everything you can point to, there are fields, not metaphorical fields, real ones. They exist at every point in space, whether anything is happening there or not. They don't wait for particles to arrive. Particles are what you get when fields do something interesting. That's backwards from how we usually think. We imagine particles as the main actors and fields as something they create. But the deeper picture flips that relationship. Fields come first. Particles are secondary. An electron is not a tiny ball moving through space. It's a specific way the electron field can vibrate. A photon is not a particle flying through emptiness. It's a ripple in the electromagnetic field. Once you see it that way, the universe starts to look less like a pile of objects and more like a continuous medium, full of possibilities. And space is soaked in these fields everywhere, even where nothing seems to be happening. That means empty space is actually crowded, not with particles, but with structure, rules, latent activity. And here's where the intuition really breaks. Fields don't live in space the way objects do. They are part of what space is. You can't peel them away and still have something left that behaves like space. So when something moves, it's not traveling through a passive void. It's interacting with fields that are already there, already active. This explains something that otherwise makes no sense. Forces don't travel the way thrown objects do. When one charged particle affects another, nothing is being launched across the gap like a tiny projectile. The field in between is already present. It changes, and that change propagates. That's a very different picture of causality. Nothing leaps across empty space to deliver a message. The message is carried by a structure that was already in place. This makes the universe feel preloaded, like the rules and responses are baked in before anything happens. And that's unsettling because it means the universe is less about interaction between separate things and more about internal rearrangement of a single system. There aren't isolated objects talking to each other across emptiness. There's one continuous entity adjusting itself locally. This also means that motion isn't what you think it is. When something moves, it's not sliding across space like a bead on a wire. It's a shift in how fields are configured from one moment to the next. Position becomes a label we use, not a fundamental feature. And now the old question sneaks back in with sharper teeth. If particles are just field excitations, and fields are everywhere, then what separates one thing from another? The answer is not much. Boundaries are fuzzy. Identity is approximate. Distinction is contextual. At very small scales, the universe doesn't care about your categories. It only cares about allowed patterns and forbidden ones. That's why the idea of a solid, indivisible object collapses under scrutiny. There's always another layer beneath it, another description that replaces the thing with a process. And space is where all of this lives, not as a container, but as an active participant in the rules. The unsettling realization here is not that space is weird. It's that objects are the illusion. They're the surface pattern, the convenient summary. The real action happens in fields you never see, responding to rules you didn't evolve to intuitively understand. Once you accept that, the universe stops feeling like a collection of stuff. It starts feeling like a self-consistent system, endlessly reshaping itself, with space as part of the machinery, not the backdrop. And if space is part of the machinery, then you should start asking what happens when that machinery is pushed to its limits. When space starts making things, once you accept that space is filled with fields, and that fields can fluctuate, a disturbing possibility appears. Things don't need to exist forever to be real. They can appear and vanish. At very small scales, the universe allows temporary violations of common sense. Energy can briefly concentrate out of nowhere, as long as it doesn't stay long enough to be noticed in the usual way. This isn't a loophole. It's built into the rules. The uncertainty in energy and time isn't about sloppy measurement. It's about what the universe permits. If something happens fast enough, the bookkeeping can be a little flexible. So space borrows energy. It creates pairs of particles and antiparticles, lets them exist for an instant, and then takes them back. No witnesses, no record. Just a faint influence on everything nearby. You never see these particles directly. They're gone before they could leave a trace you'd recognize as an object. But they leave fingerprints everywhere. They shift the energy of atoms. They modify forces. They alter how light moves. The vacuum is busy doing things behind your back. And this ruins another comforting idea. That reality is made of stable ingredients. At the deepest level we can probe, stability is an illusion created by averages. What looks solid over long times is wildly active over short ones. Now here's the unsettling step. If space can produce particles, even temporarily, then the difference between something and nothing is not as sharp as you think. Nothing is not inert. Nothing is not safe. Nothing is a dynamic state with rules, tendencies, and behavior. That leads to an uncomfortable question. If space can make particles, why does it make these particles? Why electrons and quarks instead of something else? Why these masses, these charges, these interactions? The rules seem arbitrary, precise, but arbitrary. And yet everything depends on them. A slight change and atoms wouldn't form. Chemistry wouldn't work. Stars wouldn't burn steadily. There would be no observers asking questions. Space seems to be tuned, not necessarily for life, but for complexity. And that's where people start reaching for comfort stories design. Purpose, hidden meaning. But the deeper you look, the less evidence you find for intention. What you see instead is constraint, mathematical consistency. A universe that can exist because it doesn't contradict itself. And space is enforcing those constraints everywhere at once. Another unsettling consequence follows. If particles are fluctuations of fields, and fields exist everywhere, then creation and destruction are not special events. They're routine. The universe is not built once and left alone. It's constantly rebuilding itself, moment by moment everywhere. You don't notice because most of it cancels out. The fluctuations average to zero. The noise becomes background. But under extreme conditions, near black holes in the early universe, at high energies the averaging fails. Space reveals its restlessness. Near a black hole, space is stretched so violently that what counts as a particle depends on who's watching. Something empty to one observer is full of radiation to another. That's not a mistake, that's the rules playing out. And now the idea of deep space becomes unsettling in a new way. The deeper you go, the less fixed reality becomes. What exists depends on context, on motion, on perspective, on scale. There is no absolute inventory of the universe that applies everywhere. Space does not hand you a list of things that exist. It gives you a framework for what can exist and lets the rest fluctuate. Once you see that, you realize why looking deeper doesn't bring clarity. It removes it, and that leaves one final question hanging in the air. If space is active, if it fluctuates, if it creates and destroys, why does it feel so stable to us? Why looking deeper doesn't bring peace? There's a quiet assumption we all carry, that if we understand something deeply enough, it will start to feel comfortable. Physics doesn't work that way. Every layer you peel back removes something solid and replaces it with something abstract. Objects turn into interactions. Interactions turn into fields. Fields turn into constraints and probabilities. And at no point do you arrive at a final, sturdy foundation. You just stop, not because you've reached the bottom, but because you've reached the limit of what you can meaningfully describe. That's unsettling if you're hoping for certainty. Space doesn't give you a floor to stand on. It gives you a set of rules and says, this is how it behaves. Deal with it. The more carefully you look, the less room there is for comforting stories. Space isn't empty. Time isn't universal. Objects aren't fundamental. Even cause and effect start to blur under extreme conditions. What remains is consistency, not meaning. And that's the part people struggle with. We want the universe to explain itself to us in human terms. Purpose, direction, narrative. But the universe doesn't care whether its behavior feels satisfying. It only cares about not contradicting itself. When you look into space deeply enough, you realize that reality is not built out of solid things moving through an empty state. It's built out of relationships that persist because they must. Space is not a backdrop. It's part of the machinery. And that machinery doesn't promise comfort. It allows complexity. It allows life. It allows observers to exist. But it doesn't guarantee that the picture will make intuitive sense to those observers. That's why deep physics feels unsettling instead of reassuring. Not because it's dark or hostile, but because it's indifferent. There's no preferred perspective, no absolute reference frame, no privileged location. Space treats everything equally, including you. You're not at the center. You're not even particularly special. You're a temporary pattern, stabilized for a while by the same fields and fluctuations that could unmake you just as easily. That sounds bleak if you're looking for reassurance. But there's another way to see it. The fact that the universe is intelligible at all is remarkable. That a system built on fluctuating fields and abstract rules can produce stars, chemistry, consciousness, and minds capable of asking these questions is extraordinary. Understanding doesn't give you peace. It gives you clarity. And clarity doesn't tell you what to feel. It just tells you what's actually there. Space is not empty. It's not silent. It's not passive. It's active, restless, structured, and deeply strange. And the deeper you look, the more you realize that reality is not built to match your intuition. Your intuition is built to survive long enough to ask the question. That's the unsettling discovery. Not that space is weird, but that it never owed you comfort in the first place.